Testing, testing, testing.
Hello, Dojo here, and Zero and I wanted to introduce SAPS to you guys, or Surface Attack Proficiency Series, which is a part of the larger initiative that he and I have been working on that we've been referring to as Wild Boar. So as a quick refresher for everyone, Wild Boar is a program that is meant to basically improve our proficiency in a number of areas, including surface attacks, including things like tactical turns, basically emergency procedures, defensive techniques, things of that nature. So, you know, we have ideas about how we could work and improve all those things and do it in a fun way and maybe even a competitive way. And then really just lift the proficiency level of the squadron. And so now that we finally have something concrete to show you, we wanted to show you what we've been doing over the last month, really month and a half, focused on the actual surface attack. So we started with weapons in the whole Wild Boar thing, and that led us to developing the sheet that we're referring to as the Surface Attack Proficiency Series, or SAPS. And really, I mean, obviously everyone knows what DAPS is here, DCS Attack Planning Series. We're kind of looking at SAPS as sort of the little cousin to DAPS, in that DAPS is used to plan a particular attack, and it has a mountain of data that enables you to do that very effectively, where SAPS basically allows you to analyze how you did during those attacks and over a series. So as you can see here in my spreadsheet, and it might be a little disorienting as you first look at it, but it's quite simple, I assure you. As you can see here, we can allow you to record up to 10 series in a particular run and then see and analyze exactly how well you're performing. And not just to think about that particular attempt, but also to allow you to compare it against future attempts and really see where you need work. So what I'm going to do in this video is give you an overview of the function of the sheet and how to use it. And then I'm going to show you just how effective it is by showing you some of our recent runs, and even with someone who's used it for the first time just this week, how effective it was at analyzing what he was doing. So very quickly, the sheet basically is designed in Google Sheets. You can't download it and use it in Excel yet because there's some dynamic links. We may make that possible in the future, but as Google Sheets is free, we don't really see it as a problem, and probably much more accessible to everyone. So basically, you come in, you duplicate the primary copy because you can't edit that of the sheet, and then you decide what you're going to do. So I, of course, put my pilot name in here. I choose the date of my particular attempt, and I choose the range that I'm going to be operating at. So at the moment, the tool is assuming that you're going to be operating at one of the well-known ranges. So either Black Pond, which is the range designed by Tom in OER, in Operation Eastern Resolve, or Pashenka, which is Stuka's range at Stray Bear, or Rusty, which of course is Eddie's range at side of OGS, which is the current active mission. So basically, choosing the range you're operating at will change some of the data in the sheet, which I'll get into a little bit later. And then we're going to put in our base deviation, which I'll explain a little bit later. It's very simple to do. And then we're going to decide what profile we want to fly. So the sheet is currently in alpha, by which we mean it is absolutely complete for gun runs, for the profiles that we have, of which there are 3. We're still working on getting the LAS and designing a TTS run for this. We should have those things hopefully shortly. But we also intend, of course, to put bombing profiles in here, as well as rocket profiles, et cetera, et cetera. So once we have all of that stuff in, you know, we'll kind of call it beta/final. I'm not married to what stage things are in. It's just, this is clearly not the full intent of it. However, even at this early stage, you can use this sheet very effectively to analyze how you're doing with, let's say, your gun runs. And these things are actually building blocks for when you were doing bombing things, because really the base altitudes and things like that, the dive angles, all of that stuff remains true regardless of what type of attack you're doing. It's just a question of what type of offset you might be actually flying. So as you can see here in this range selector, I can choose between the profiles that are available to me. And doing so does a couple of things. So for example, looking at my 10 LRS 12K, you can see here's my profile data, and then switching it here to the 30, you can see my profile data there. Now, we recognize that the gun sleds may not be familiar to everyone, so let me just quickly give you an example of this sled and exactly what we're doing in this sheet. So this is a 10 LRS 12K slant range, meaning that your intended dive angle is 10 degrees or less. It's a long range strafe, meaning that it's probably between a minimum distance to target of 0.8 miles, because once you get to 0.7, you're pretty much in low angle strafe territory. And this is a 12K, meaning that your intended slant range when you fire is 2 miles, right? So roughly 6,000 miles, 6,000 feet per nautical mile, right? 6,076. And so that's going to get you to a 2 mile slant range, meaning if you were actually aiming at the target, you're looking for 2.0 with the gun cross on the target. So that's our intended profile here. And our base altitude would be 3,300. Our track altitude is 2,500. Base distance is about 2.5 nautical miles. A fire altitude of 2,200 and an abort of 400 feet. And all of these, of course, are AGL. And so just one thing about these profiles, as Noodle explained to us, these are A model sleds. In other words, if you were to compare this to one of the sleds you might see in the battle book for, let's say, Mark 82s, you may note that, the tick here for release is in the middle, and then there's abort, and then I think there's a min out for training. And the A models are a little bit more condensed. So again, as I wrote here, base, track, release, abort. And these are computed deliveries. So we're not going to focus at all on any of the manual parameters. Really, that stuff is out of the purview of this tool at this time anyway. And Zero and I, quite honestly, don't possess the knowledge yet to help anyone with their manual deliveries. That's all stuff we aspire to learn in the future. But since the overwhelming majority of what we do is computed deliveries, we thought it'd be really cool to see just how well we were doing and look to improve that. So in this case, because I'm doing a 10 LRS, what the sheet is going to do is take into consideration the range I'm operating at. Now, as this is a gun particular profile, this is a gun profile, we're going to be hitting the strafe pits. And so we're concerned with the attack heading and the elevation of the strafe pits. And as you can see at Black Pond, we've actually coded in what the attack heading is and what the elevation is of that target. So if I choose Pashenka, for example, which has an attack heading of 180 and the strafe pits have an elevation of 82. If we look at Rusty, strafe pits have an elevation of 1,000 and attack heading of 210. And that's not just for your information, that's actually processing here against this profile. So really, if we were doing a 10 LRS at Rusty, right, we've got 1,000 feet of elevation. So our true base should be 4.3. Our desired track is 3.5. Our release 3.4 and our abort 1.6. Now, you'll notice that the base and the track are just 1,000 feet more than what's here in the profile, but you'll notice that the release and the abort are about 1,200 higher. I will explain that towards the end of the video. Just trust us, we're calculating the deviations for you. So what it's also going to tell you is your delivery specific parameters. In other words, this is a 10 LRS 12K, so you should have a desired slant range of 2 miles. So again, I've got my gun cross on the strafe pit, so on the chute that's in the strafe pit, and I'm looking for a slant range of 2 nautical miles before I actually make that trigger pull. And again, I certainly don't want to be firing after 0.8, or else I'm not really doing an LRS anymore. So once I've done that, very, very quick, come in here, pop my name, choose the range I'm at and the particular profile I want. Let's choose this 30K here, right? As you can see, when I choose that, the profile changes and these calculations change as well. Additionally, the safe escape maneuver is changing also, right? Just besides the calc. So the 30 has a climbing RTSC. So if you just go back and look at the LRS, you'll notice that's turn, level, turn. So working here from my 30 has and switching this to Pashenka, which is the range that we like to operate at, just the visual references there are awesome. Then we get our intended profile that we're going to apply. So we basically have a desired base of 7,600, track of 5,600, and a release of 5.2. Really, as these are gun runs, we're going to be focused more on the slant range. So 9K, 9,000 feet, is going to be a mile and a half, right? 6,000, 3,000, mile and a half of slant range. That's what we're going to be looking for in our actual run. So then what we do is we go to the range. We have to do one thing when we get in the cockpit. We basically fly to our base altitude, level out, and then hit the F2 key and write down the deviation. I'm going to explain a little bit later more deviations, but the very simple thing you're doing here is you write down the number. Your HUD is going to say 7,600 feet. When you hit F2, there's going to be a different altitude, and you record that difference. So let's say that you're at 7,600 and the F2 view shows 200. You just plug it into there, and that will make all of your Tack View data accurate, or as accurate as we need it to be for this sheet. So let's now look at a single run and how you actually use the sheet. This, again, is really meant to be used with Tack View so that you can analyze what you're doing. So it's not a standalone tool, but using it with Tack View is very, very effective. So what you're looking at here is I made 10 passes at Pashenka doing the 30 has profile. Now, I'm not going to waste your time and show you all of these, but I am going to do at least one so you can understand how I populate the sheet. And so just to give you a rough estimate of time, right, this is a series of 10 attacks that I attempted. But of course, with training rounds, you've got a 1150 TP loaded on the plane. So I can make 10 rounds firing at 100 rounds per event, which is what, by the way, you should be aiming for, right? So desired number of rounds per attack is going to be 100. So since that's what I'm aiming for, I know with 1150, give or take, some rounds, because I'm probably going to overpull or underpull a few, I should be able to make about 10 to 11 runs. So nothing stops you from just doing 3. The sheet would totally work if you did 1, 2, or 3. But again, it can support up to 10 at this time. So what I want to do is I'm going to jump to the particular first event. So if this were a long Tack View, right, where I took off from the airfield, this was an air start mission, so it's a relatively short Tack View, where I just started right over Pashenka, flew right to the range, and then started attacking it. Basically, I would just double click on the first firing event, and I would start to get my data. Now, of all of the data you're recording in the sheet, a couple of them are not so straightforward, and there's really nothing at this time we can do about it. We've actually been in contact with Virtuos, who's the developer of Tack View, and he is very supportive and very interested in what we're doing, and actually is making quite a few enhancements that will make this even easier in the future. So what we're doing right now is we're going to basically do some estimations for base. And it's really easy to do. Base is just a little bit of a pain in the butt. So what you do is you jump to the firing event. It doesn't matter which one, right? Let's say that I looked at this event. What I'm going to do is just rewind a little bit to when I'm on my base, right? So that's my final, and here I am back on base. So all I want to do is play the video, and I tend to do it at about half speed, and essentially record my ASL altitude, which is currently showed here in this HUD view, when I make my roll to final. So the moment I start my final roll, I want to record that altitude. Just one note about altitudes looking in the HUD view. When you're above 5,000, it will show you ASL. The moment you go beneath 5,000, the HUD view switches to AGL, and actually you'll see the number, you'll see the letter R here next to this number. So again, doesn't matter because you can always get both values here. So I'm actually recording this video on my laptop. When I do this on my PC, I'm much faster because I have a mouse instead of a trackpad, to sort of go back and forth. But again, all I'm going to look for, and it doesn't actually take me this long, I'm just talking over it, so I'm not really focused on what I'm doing. But basically, the moment I start that roll, that's when I record the altitude. So let's just call it, for the sake of this video, let's call it 7711. Okay, and you can see here I plugged in that 200 number because when I flew in the sim, I realized that at 7,600 feet, the sim was actually showing me 7,800, and that's what all of these Tack View values are based off of, what you see in that F2 view or your true ASL. So that's why we're doing that that calculation, but it's very, very straightforward. So I like to record all of my base altitudes first. So I'll, go to the first event, obviously rewind it a little bit, and then just do that because that's the most pain in the butt one to do. So I just like to record my base altitudes across the board. All right, so I'm not going to be perfect on this just because I want you guys to see what I'm doing. Then after I've recorded my base, I double click the firing event, and I get quite a bit of data from doing that. So on this particular event where I fired 106 and I hit 84 times, the first thing I look at is my slant range, 1.3 nautical mile slant range. I can see that because my aircraft is selected here and the strafe pit I'm hitting is selected there. So you just choose your target here from the drop down. The nice thing is in DCS, in Tack View, once you double click that, it should actually do that automatically for you the first time unless you've changed these selections. So here I can see when I started to fire, 1.3 nautical miles, my heading was 184, my dive angle was 30. So let's go plug that into the sheet. 1.3, 184, 30. And I fired 106 rounds and I hit 84. So as you can see, I got quite a bit of data right here in this part. So now what I want to do is I slow down to half speed. Looking here, that's a quarter. Slow down to half speed, and I pause the video at the moment I stop firing. Now this is my in-fire slant range, 1.1. The other value I get at this point is my abort altitude. Now, our rule of thumb is to use whatever altitude you have here in ASL when this number is between 1.2 and approximately 1.4 G, right? So you're just starting to pull back on that stick. You're not going to be super accurate here, and that's okay. We have enough slack built into our tolerances, so that won't be a problem. I mean, at some point we had to sacrifice because you just can't measure the exact moment. And you can look at 1.1 and call that, but we think it's reasonable to do 1.2 and 1.4 G. So basically I'm just gonna play that until after I stop firing. Now I'm doing it too much here. Again, I'm on my laptop, so I'm struggling with the stuttering of the video. But on my computer, this is super easy with my mouse. I just slow it down, play it. As soon as I stop firing, I normally catch it at 1.2 G and just record that altitude. So this is much higher. Let me just bring it back a little bit. All right, let's just do that number and call it 4396. So 1.1 was my in-fire slant range, 4396. And as I said, we've got enough slack built into these numbers where, if you're a couple of 100 feet off, it's not gonna cause you much grief. So the last two things I want to look at is my safe escape maneuvers maximum G, as well as my maximum pitch. Now, technically, for a safe escape maneuver, you're supposed to pull 4G within 2 seconds. It is extremely difficult at this time to measure the time frame at which you reached 4G. So we're not doing that. We're only asking that you have basically a G that is around 4. So in other words, you don't want it to be, I forget what our actual tolerances are here, and I don't want to waste your time looking it up. But basically, let's say between 3.5 and 4.5 is the G you're looking for. If you're over 4.5, you're violating the sim. Right, so that's what we're looking for, and it's really easy to record G because I can basically play at full speed and just watch where that number tops out. So here we can easily see that it tops out at about 3.9, and so the next thing I look at is in the HUD view, what was my maximum pitch angle? So the climbing safe escape maneuver, for example, doesn't terminate until you reach 30 degrees of climb. So whatever number you stop at above that, but it's got to be over 30 in order for it to be valid. So that was about 31. And then I'm pretty much done. And I assure you, if I wasn't walking you through that, I could fill out 10 of these in 10 to 15 minutes. It really doesn't take that long at all. When we first started, we were slow because, you kind of have to develop the muscle memory to know where to go in the track and how to rewind it and where to pause it at. But you get very, very good at it over time. And again, I've probably done like maybe 6 of them, and I'm down to 10 to 15 minutes for 10 series. That assumes you do 10, right? If you do, 5 or whatever, it's going to be half that. So it doesn't take long at all. But the value we get out of this, of course, is the results down here. So what we're seeing now is based on my base altitude, I was approximately 71 feet off, but I was in the green. My firing slant range was, 0.2 off of what my intended, because I fired at 1.3. My attack heading delta, I was 6 degrees off. You're allowed to be 10 degrees in either direction. So here, my desired is 180. So I can either be at 170 or 190, anywhere between that, right? But anything outside of that would be a violation. My dive angle, as you saw in the video, I was right on 30. I'm sorry, in the tack view. My hit percentage was pretty high. Slant range violation, nope, because I stopped at 1.1, didn't get near 1.8. I'm sorry, 0.8. Board altitude delta, G limit violation, and sim violation. So technically you could look to see if I pulled G, this 3.9 within 2 seconds. You could use the G chart that is in the professional version of Tack View. I'll very quickly show you that. So here I am looking at G. So, each of these bars here is 5 seconds. So I can see that actually this pull up to about 3.9 was actually took me around 5 seconds. So that actually wouldn't be that good. But again, at this time, we're not looking at that. I just wanted to point it out if someone was interested to know, there's a ton of data that you can get here. We're just not going to require people to collect all of it. So now that I've done this, I kind of want to show you guys what this looks like at the end state, right? So I'm going to put Iron Hog on the spot here because he was incredibly awesome and volunteered to be our guinea pig. Zero and I have been buried in developing this sheet over the last month and a half. And so, we kind of know where everything is. We wanted to see how someone who was just introduced to it for the first time would take the sheet, make these runs, how he would perform, and then how he would be able to analyze himself and improve. So I want to show you a couple things. Number one, this is Iron Hog's first attempt. So although there are no perfect runs in here, you can see that there's quite a bit of green, and we can already see the trend, right? So his first run, his very first time doing it, was the worst, right? 30-degree intended dive angle, he had 18. But then look at the average after that, right? Because we were kind of just making these runs around the track. So this isn't the sheet. This is just being at the range and making those circuits. He just quickly started adjusting himself and really improving. And he got really close to perfect on at least 5 of them. He just had G limit violations all across the board. So you can see here, right, that he was constantly over G'ing. So the point is, looking at the sheet, that tells him right away, well, I need to lighten up my stick pull when I'm executing my sim, right? I'm probably pulling back a little too hard, right? Certainly so if he's always over 4.6. So, again, I don't show this to put Iron Hog on the spot. I show it to say that, this was someone doing this the first time. He recorded it, and he was actually able to get a wealth of information about how he executed his attack. What Iron Hog and I actually did while we were populating the sheet was we compared our runs. And so again, now I've done it a few times, so my sheet's a little bit better than his, right? Not significantly, because I still suck at this, but it was a little bit better. And so what we were doing, and we ended up changing some of the data, but when we first did this, my abort altitudes, I think I only had 2 where I didn't pass, and then Zero and I made some adjustments, and it turned out that there were actually 4 because I made some mistakes initially. And so we were looking at this and we were trying to figure out, well, why was Iron Hog's abort altitude? So this is me and Iron Hog, the very first time he used the sheet. Why was his abort altitude? Why did he violate it less than I did? And usually that's a base distance thing, right? If you're too far out in your base, then you're in a shallow dive and you end up, by the time you're within range of the target, you're lower than you should be, even though the dive is shallower. So we were looking at that, but it turned out that both of our base distances were pretty much the same. And then the sheet revealed what the problem was. And that was, if you look at my firing, I was averaging around 98 rounds per firing event, right? Which is our intended desired number of rounds, right? So we're trying to aim for 100. So I've developed the muscle memory to make a 100-round trigger pull. Whereas this was Ironhog's first time really doing this, and you'll see he was firing significantly less than I was, basically about a third on average, less time he was holding the trigger, which means he was aborting sooner than I was. And so just looking at this sheet, literally within 2 minutes, we were able to figure out something he was doing that I wasn't doing. And now he knows, all right, I need to hold that trigger a little bit longer. I need to lighten up that stick pull. This is just by comparing what he did and what I did. And to really show you how effective the sheet is, this is a run we did earlier in the week. So this is my run here. This is my very next 30 has attempt, the very next one I did. So obviously, guys, I'm showing this to demonstrate that looking at my own data, figuring out what I was doing wrong, going back and correcting and flying again, I was able to get substantial improvement. So even if you don't focus on what all improved here, you can see I basically made 3 mistakes, but overall, my first 5 runs were within our tolerances here. So again, we hope that, this sheet is, like I said, it's alpha, but it's fully functional for guns at the moment. And we're happy to extend it to anyone who wants to use it. You can make a copy of it and then start to use it right away. It's free, of course. You don't need Excel or anything. And the last thing, you can leave the video right there if that's good enough for you. I just wanted to quickly go over our tolerances and the built-in slack for anyone who's interested to understand how we're doing our calculations here. So one of the first things to understand is the actual tolerances. So for every profile, we've got this sort of tolerance table here that's basically telling you what we're looking for. So in the 10 LRS, and let me just go back to a clean version of the sheet here. In the 10 LRS, we're basically looking for your base altitude to be within 200 feet. And that's taking into account the additional deviation, right? For your fire slant range, you've got 0.1 nautical miles of tolerance. So if you're intended to be at 2 nautical miles and you're at 1.8, that's a fail, right? And in fact, 1.9, good. 1.8, bad. Okay, so and that's going to change, right? Your attack heading, your dive angle delta, your hit percentage. The higher the dive angle, the more accurate you should be. And we've been doing this a lot. Our percentages, especially with the gun accuracy mod, have been very high. We intend to validate some of those numbers with Noodle and Eddie. But yeah, that stuff's been significantly high. We think it's correct, but we just want to double check. So what we've done, if you now look at the 30, we require 40. Zero and I are averaging above 70%. So we don't think that that's a problem at all. Honestly, on Zero's first 60 has run, he averaged, we have 80%, which is really high. Zero averaged 100%. We reviewed his Tack View and my Tack View, certain of it. So we believe that this is correct. We'll go into that later, why we think so. But again, just wanted you to understand the tolerances that we're looking at. So some of the slack we had to build into the tool comes from the fact that, you have to take into consideration the fact that you're using Tack View to measure this. I'm sure a lot of you guys have seen, I've made quite a few posts recently about Tack View accuracy. It was all in doing analysis for and the development work for this sheet. So we solved the issue with which Tack View to use. You should always refer to the Tack View of the person shooting, just because of the things not transferred over the network from DCS. That's always going to be the accurate Tack View, the one of the person who actually did the firing. So basically, we're using that, and what we saw was specifically for your base distance. Again, you should measure as soon as you get in the pit. It's very easy. You're on your way to the range. You level out at your base altitude, hit the autopilot, hit F2, write down the number. That's all you have to do. Done. And then the difference between that number and your intended base, you plug it in here to this space here. Done. The sheet will do the rest. Everything else we're calculating for you. So a couple other examples of things that are problematic. At Pashenka, the strafe pits in your cockpit if you're flying directly at the strafe pits, you have a heading of 180. So that is your desired attack heading at Pashenka. If we were to open up Pashenka in the mission editor, you would see that the actual heading is 186, right? So that's the difference between the magnetic and the true, at least from DCS's perspective to your cockpit's perspective, right? If you hit the F2 in the cockpit, you've got a constant 6-degree deviation no matter where you are on the Black Sea map. Tack View, however, has a variable deviation. So at Pashenka, if I'm heading 180, Tack View will show 190. So we had to basically take that deviation for each of the ranges, and it's already built in, so you don't have to worry about it. So all you do is you choose the range you're operating at. At Rusty, by the way, it's 14.6, so we rounded up to 15. So although your cockpit will show 210 if you're flying straight at it, and the mission editor will show 216 if you look at the particular strafe pits, Tack View will show it has a heading of 224.6. So we basically built that in. You don't need to do any math at all. Just choose the range, fly the desired attack heading. We will do the rest. So if you were looking at your attack heading, for example, so if you were looking at Pashenka, as I'm doing here, with the desired attack of 180, and we come in and we look at one of my profiles here, we'll see this attack heading of 184. You can see I'm slightly turned. Let's see one where I'm a little more lined up. Yeah, here's 192, right? So that's 12 degrees off of what we think it is. Again, this is what Tack View is saying. But when I plug 192 into our sheet, again, we're going to go ahead and do that math for you. And really, you're not 12 degrees off, you're only 2. So all of the different deviations and tolerances and all of the idiosyncrasies right now of what's in the sim and what we get out of Tack View, we've pretty much built in the deviations where they're fixed, like the attack heading, and we've built in some tolerances for things like altimeter lag. So for example, if you dive from, let's say, 10,000 to 6,000 feet, and when you cross 6,000, your speed's around 375. If you look at your HUD is showing 6,000, but if you actually hit F2, you'll see you're probably around, 53, 5,400. So, depending on your dive angle. So we basically had to build in that altimeter lag, if you will, and also account for the deviations that are in the sim. And so what we're doing as a very, very broad rule of thumb is 20 times your dive angle will be applied. So in other words, if my intended dive angle is 60, then we're going to give you 1,200 feet to apply. If my intended dive angle is 10, then we're going to give you 200 feet applied to it. That is why, by the way, if you look at the planned 10 LRS attack profile, and you see that for, let's switch back to Rusty because it's a nice even 1,000 number. You see that Rusty's got an elevation of 1,000 feet. Then this number should go to 4.3. It does. This number should go to 3.5. It does. But this number doesn't go to 3.2. It goes to 3.4 because our intended dive angle is 10. We multiply it by our rule of thumb, which is 20. We had 200. And so it's 1,200 that's being added. And that's why your desired release is 3.4 and your desired abort is 1.6 because you're in that dive for these two particular altitudes. So we're applying our general rule of thumb there. And we found that it works quite effectively. Again, if you're actually using the sheet, you don't have to worry about it. Just write down the values you see in Tack View. We're doing the math for you. So still a work in progress. Like I said, we're calling it an alpha because it doesn't have all of the profiles that we want in it, but the tool is extremely effective. As you see, sorry, I switched the profile out here, but as you see from run to run, dramatic improvements just by analyzing what I did and then going and attempting the run. So we really hope you guys appreciate it and are interested in it. And please, let us know, respond to the forum post and let us know if you're interested in getting access, and we'll happily share it with you. And of course, we'll answer any questions. We'll continue to develop stuff like this for wild boar. And once it's a little more baked, we estimate we've probably got another couple of months to finish it up. We will happily present that and hope everyone's interested. It's all about making us better. So we really hope you appreciate it and participate. Thanks, guys.